Hey there, Chem Squad. In today's class, we're going to look at a Type 5 equilibrium question. The Type 5 is the last type and probably one of the more difficult ones. It does involve the use of quadratic equations and quadratic formulas. So let's look at what makes this particular question so challenging. At first glance, it doesn't seem like it's a tough question. Okay, because when you kind of look at what you're given an initial concentration of a certain substance. So in this case, PCl5 is 0.0555, sorry, 0.550 molarity, and then it gives you the KEQ, which is equal to 0.600. What they want you to find is the molarity of each substance at equilibrium. So right off the bat, it sounds like this is a type 4. Okay. Now, when you go through the checklist of things to keep track of, okay, in your steps, we always again start with a balance equation. Okay. So when we look at this particular equation, reaction here, it gives us a 1 to 1 to 1, so it's already balanced. You have 1 phosphorus on both sides and 5 chlorines on both sides as well. You check for molarity. It seems like our initial concentration is in molarity, so we don't have to do anything different. So that also takes care of step 3, check for initial concentration. So again, if there is an initial concentration, we need an ICE table. Okay, so right away we know that an ICE table is something that we're going to eventually use. The next thing that you want to check for is whether or not an equilibrium concentration is given. Now, it's asking you to find the equilibrium concentration of all the substances. So no equilibrium concentration is given. So if it's not given, you're now left with a type 4 or 5 situation. So what I usually tell kids is you treat this as a type 4 and you can just keep doing the math. At some point, you're going to run into a problem. Okay? When you run into that problem, you'll realize that, oh, this is a type 5. You're not going to be able to figure out whether it's a type 5 or not until you get to a certain point in the work, in the process. So, we basically carry on thinking that this is either type 4 or 5. So we are going to set up an ICE table, and we're going to use X here as the amount of change, okay? Because we're not given equilibrium concentrations, so we can't work backwards. You're going to do the same thing as in a type 4 and start setting up your equilibrium expression, and you're going to start solving for X. So step 7 is the key step. When you get to this step here, you're looking at your question and you're trying to figure out, hey, is there a way for me to square root? Okay, kind of like what we did in a type 4. If not, okay, if that's not possible, okay, mathematically not possible, then you have a type 5. So steps 8, 9, and 10, they're all dealing with excuse me, what happens when you have a type 5 situation and how you're going to use the quadratic equation and the quadratic formula. So the quadratic equation is this one here. I think this is something that you should have gone through in grade 11 pre-cal, but basically it's xa squared plus bx plus c, okay, and we set it to 0, meaning that it's going to, all of this equals 0. Okay, once we have that, what we actually want to find out is what is our A, B, and C values, because we're going to use those values to put into the quadratic formula. And when we put it in the quadratic formula, the whole point of it is to solve for X. So let's get started with this particular example. Okay, so you're going to set up the ICE table. So we have PCl5 as our reactant. we have PCl3 as a product and Cl2 as a product. Okay, and like we said before, this is in a 1:1 ratio. Okay. ICE stands for initial concentration, change in concentration, and equilibrium concentration. We are only given one value. We were given that the reactants had an initial concentration of 0.0550 molarity. Okay. Because it's the start of the reaction, we can assume that we have 0 products, so 0 concentration. Okay. Since the reactants are going to be used up to make products, we give the change a negative sign for the reactants. For both products, they're going to be positive. Okay. Now, since we don't have any equilibrium concentration, we're going to let X equals the amount of change. So X is going to represent the amount of change, so we put it into the change row. The molar ratios only affect the amount of change, and because they're 1:1:1, they all change by the same proportion. So when we look at what our equilibrium concentrations would be, PCl5 would be 0.0550 minus X. 0 plus 1X gives you X. 0 plus 1X also gives you X. So the equilibrium concentrations for PCl3 and Cl2 are both X's. PCl5 is 0.0550 minus X. So now we need to write out our KQ expression. Now, we are actually given the KQ value in our question. So the given value of KQ is 0.600. And that is going to equal our products. So PCl3 times Cl2 over the concentration of PCl5. So at this stage, again, nothing new. We're just going to substitute the equilibrium concentrations into the expression. Okay. So when we substitute it in, I'll just go one more down. The problem now looks like this. So you have X times X over 0.0550 minus X. Now, keep in mind, if we simplify this just a little bit, X times X is X squared. But the problem is, in our denominator, we don't have a square. This is basically by itself. So what this means is you cannot take the square root. So cannot take the square root And since you can't take the square root, we can't simplify this in that manner. Okay, so the only thing that we can do now is to cross multiply. Okay, so we can't take the square root, but we can cross multiply. So that means x squared ends up being equal to 0.600 times 0.0550 minus x. Okay, so at this point here, we want to set up the quadratic equation. Okay, so remember, your quadratic equation is ax squared plus bx plus c, and we want to equal 0. Okay, so that's the format that we want to arrange our formula here. So what we have to do first, we have to distribute 0.6. So we have x squared equals 0.600 times 0.0550. That comes out to be 0.033. Okay, and then you go 0.600 times minus x, and that'll give you 0.600x. Okay, so we now move everything over to one side so that we can set it to 0. So when I move everything over to the side that has the x squared, okay, positives become negatives. Oops, sorry. Actually, before I do that, might as well do it in the right order. Okay, so let's move negative 0.600x to the other side. The negative here becomes positive. The positive value of 0.033 now becomes negative. And it's all equal to 0. So this is the quadratic equation. Okay, so the coefficient in front of the x is actually a 1. So this is a equals 1. The number in front of the x is positive 0.600, so that equals b. And our c value is negative 0.033. Okay, so excuse me, the whole point of setting up the quadratic equation is so that we can get a, b, and c. The a, b, and c is now used to put into our quadratic formula. So now set up quadratic formula. Okay. Our quadratic formula is x equals negative b plus minus the square root of b squared minus all of 4ac divided by 2a. So you're not given the quadratic formula. That is something that you will need to memorize. So what we do now is that we substitute a, b, and c into the quadratic formula and then do the math to solve for x. So remember, you have to have that negative sign there. Okay, b is 0.600. Okay, plus minus the square root, and I usually write this one longer because there's more stuff in here. B squared, so again it's 0.600 squared minus 4ac. Now I put the big brackets in here so that we have 4 times a, which is 1, times c. Now c, remember, has a negative sign. Okay, so just double checking to see if that's the right number. It is. Close the big bracket. Okay, and then divide the whole thing by 2 times a, which is 1. Okay, so now we're going to do the math and simplify this entire calculation. Now some of you guys may have graphing calculators that have the feature of punching in your a, b, and c, and then it spits out your answer. Okay, but remember, I'm marking you based on whether you can do the work. So 0.600 plus minus. Now I'm going to show every step. Okay, and I know that when you're doing the work, you probably won't show every single step. Okay, but I do want you to show at least some of the steps. So 0.6 squared becomes 0.36. Okay, minus. Now everything in this big bracket here comes out to be negative 0.132. Okay. Now mathematical laws say that you cannot have a negative sign underneath the square root. So that's good that we have a negative sign here and negative sign on the inside. Okay, because negative times negative is a positive. But remember, all this is over 2 times 1, which is now 2. So if I simplify this again, everything underneath the square root here, once you have 0.36 plus 0.132, that will give you 0.492 over 2. So now you can finally punch this into your calculator to actually solve for the square root there. It turns out that the number equals 0.70 divided by 2. Okay, so we've now simplified the numerator. At this point here, there's 2 possible solutions for x. Okay, because of the plus minus sign, we can split this into 2 possible values. X can either equal negative 0.600 plus 0.70 divided by 2, or x can equal negative 0.600 minus 0.70 over 2. Okay, so if we do both calculations, this one here ends up being equal to 0.05 molarity. Okay, this one here ends up being a negative value. Okay, because you're going to have a negative numerator and the whole value will be negative. We typically can't have negative concentrations. Because a negative concentration doesn't mean anything. So we typically have to reject the negative values. Okay. Now, I want to make another point. There are some cases where x will be two positive values. Okay, so there's no negative value calculated. In that case, you always want to take the smallest positive value. Okay, so in this situation, the clear winner is 0.05. Okay, but just as a note, always accept always accept the smallest positive value. Okay, so again, if there's a situation where both x values are positive, you always want to take the smallest one. Okay, that's just being a little bit more conservative with our calculations and assumptions. So we're almost done, because once we have x figured out, we can use x to substitute back into our ICE table to find out our equilibrium concentrations. So therefore, at equilibrium, the concentration of PCl3 is the same as the concentration of Cl2, which is the same as X, which is therefore 0.05 molarity. And for PCl5, the reactant, okay, it was equal to 0.0550 minus X. Okay, so we just substitute the X value in, and we get 0.005 molarity. Or, if you want to write it in scientific notation, it's 5.0 times 10 to the negative 3 molarity. Okay, so those are your equilibrium concentrations. Now, this is a lot of work for one question. Okay, it's a 10-step process, and it's very easy for you to make a mistake somewhere. Okay, the most common mistakes is either forgetting a zero, switching up a sign, perhaps doing the calculations for your quadratic formula incorrectly. Okay, there are many places where you can make a mistake. So that's why on your assignment, I do give you the answers to the questions, and what I'm asking you to do is to show me how you are going to solve it. Okay, show me the work. So if you are the type of person who do math by writing out the steps, that's actually pretty good, because if you do make a mistake, at least you can go back and look at where you might make a mistake. Okay. Now the most frustrating thing is you do all the work and all of a sudden your answer doesn't match up with mine. Okay, and we're not talking about round off error. We're talking about, oh yeah, it's definitely not the right number. So you're going to go back and you're going to look at your work, but you still can't find where you made the mistake. Okay, that is frustrating. Okay, but sometimes people will go through the question again and again and they still can't find it. And then when they finally do find out their error, it usually is some kind of tiny mistake. Okay, either again missing a decimal place somewhere here or missing a sign. Okay, it's usually not a major math problem. It's usually a minor math mistake. So when you do this, I just ask you to try and be as careful as you can and do your best. Okay, you'll eventually get the hang of it. Now, a lot of these questions here, type 4s and 5s, let's say you do a type 4 and you forget to square root. Well, you can still basically use the procedure, okay, for type 5, like quadratic equations, quadratic formulas, to solve a type 4. Okay, it's just that it's more work, right? But you still get the same answer. You can't do it the other way. If it's a type 5, you have to use a quadratic. Okay, there's no way that you can cheat and try to square root something that can't be squared root. Okay, that would be a math mistake and that would lead you down the wrong path. Alright, that's all I have for today. If you do run into any problems on the worksheet, please let me know and I'll try to help you as best I can. Thank you for your time.